Welcome to this lesson on how to differentiate an algebraic expression like this one here, y equals 4x squared plus x all over x. And the first step is to split this into two fractions, and you get the first term over the denominator plus the second term over the denominator, as I've done here in this second step. So 4x squared over x plus x over x. And a simple example will explain why you can do this. Now 1/4 plus 2/4 is equal to 3/4, and the step in between is really the two top numbers added together all over the denominator 4. And so really in what you're doing in this example here is you are going from this step back to that step. You're separating this into two separate fractions with the same denominator. And that's what I've done here. And then it's a matter of simplifying both of those terms, getting rid of the fraction. And the rule when you're dividing indices is subtract the powers. So it's always top minus bottom number, and this x on the bottom is really x to the 1. So you end up with 4x to the 2 minus 1 plus, and then any number divided by itself, or any term divided by itself, will always equal 1. And simplifying this, you'll get 4x to the 1 and then plus this 1. And I'm keeping these powers here so I can show you all the steps in differentiating in case you've forgotten them. And the rule is you bring down the power, that's the 1, multiply it by what you've got here, which is 4, and then subtract 1 from that power here. And I've done that 1 minus 1. And the derivative of any number is always 0. And in fact, any constant term, the derivative of it is always equal to 0. And so the next step, 1 times 4 is 4, and then x to the 1 minus 1 is 0, so 4x to the 0. Any term to the power 0 is equal to 1, except the number 0. 0 to the 0 is undefined. And so you end up with 4 times 1, which equals 4. And that's the answer to this one. That's the derivative of this expression up here. Much easier to do this method than use the quotient rule. You will get the same answer with the quotient rule. It will just take you more steps and more time to do that. And it's really a harder way of doing it. In this second example, y equals x squared minus x over x cubed. And this time the denominator, the power on it, is more than the powers on the two top ones. Now it doesn't really matter what the power on the term on the bottom is, just follow the index laws. And so the first step before doing that is to separate these into two fractions, as I did in the first example. So you end up with 6x squared over x cubed minus x over x cubed. Then the rule, subtract the powers, so 2 minus 3 as I've done here. So keep the base, and that's the x. Subtract the powers, minus, and then x to the, and the power on this x is a 1. And so it becomes 1 minus 3. Next step, you get 6x to the minus 1 minus x to the minus 2. And then from there it's easily derived. And again, that's done by bringing down this minus 1, timesing by the 6, and then subtracting 1 from the power, minus, and then bring that power down, minus 2 times, and then subtract 1 from that power, so minus 2 minus 1. Next step becomes minus 6x to the minus 2 plus two negatives become the positive here, and then 2, and then minus 2 minus 1 is minus 3. And if you've been asked to express your answer with positive indices, then all you do is this step here. So minus 6 is really minus 6 over 1 times, and then this is a short way of writing 1 on x squared with a, so really just the power becomes opposite of what it is here on the bottom. And then the same here, that becomes 2 over 1 times 1 over x cubed, and then multiplying fractions, minus 6 times 1. I'm just going to actually go 6 times 1 is 6, and 1 times the x squared on the bottom is x squared, and put the minus in front of the whole term. You could put the minus there if you wanted, or on the bottom if you wanted. But most of the time in answers you'll get it's written as minus, and you really need to be able to write terms with just the minus in front of the whole term. And this becomes 2 on x cubed. And so that's the derivative of this expression up here without using the quotient rule. So that's how you differentiate an algebraic fraction without using the quotient rule. And I'll see you in the next lesson.